What if I told you that you could save a lot of energy, reduce costs, and even make your VFD system more efficient just by connecting their DC buses together? Sounds interesting, right? But how does it work, and what are the real benefits? Welcome to Instrumentation Unlimited channel. If you're into industrial automation, motor control, and power efficiency, you're in the right place. Stick with me for the next 5 minutes, because I'm going to break this down with real-world examples, proof, and even some limitations you need to consider before trying this setup. Let's get started. Imagine a crane lifting and lowering loads. When lowering, the motor acts as a generator, converting mechanical energy into electrical energy. Normally, this energy is wasted as heat through braking resistors. But with a shared DC bus, that energy can be redirected to another VFD that needs it, like a second crane lifting a load at the same time. In elevators, when one car descends, it generates power. Instead of wasting it, the energy can be fed to another elevator going up, saving 30–40% on electricity bills. Factories using this setup have reported up to 40% energy savings, reducing electricity costs significantly. In a normal VFD setup, braking resistors are used to dissipate excess energy as heat. That means wasted electricity and extra cooling requirements. But if we connect the DC bus of all VFDs having the same DC bus voltage level, the excess energy is used instead of being wasted. No braking resistors mean lower hardware costs and less maintenance. Instead of each VFD rectifying AC power separately, a shared DC bus allows a single rectifier unit to supply multiple VFDs. This reduces total harmonic distortion, THD, improves power factor, and lowers the overall load on the electrical supply. In a textile factory, multiple VFDs run different machines. Instead of each drawing power separately, a common DC bus helps distribute energy more efficiently, reducing peak demand charges. What happens if one rectifier of VFD stops working? In a traditional setup, the motor shuts down, but with a shared DC bus, the other VFDs can still run, improving system reliability. In paper mills, where multiple rollers run on separate VFDs, if one drive fails, others can temporarily take over to keep the process running, reducing downtime. Limitations and challenges of a shared DC bus system. Proper load balancing. Required. If energy usage is not balanced, voltage fluctuations can occur. You need proper DC bus voltage regulation. For that, you need to have the same DC bus voltage level of each VFD, if possible, of the same manufacturer. Protection and isolation needed. A fault in one VFD can affect others, so fuses, diodes, or circuit breakers are required to isolate faulty units as protection gears. Synchronization issues. It is very difficult to have different VFD brands have the same DC voltage levels. Ensure compatibility before connecting them together. So connecting multiple VFD panels via a common DC bus can significantly increase energy efficiency, reduce hardware costs, lower power supply loads, and improve system reliability. However, it requires proper engineering, protection mechanisms, and load balancing to ensure stable operation. For that, OEM may be consulted before doing the arrangement. If you found this information useful, hit that like button, and if you haven't yet, make sure to subscribe to Instrumentation Unlimited for more industrial automation insights. Let me know in the comments, have you ever worked with a shared DC bus system? What challenges did you face? Thanks for watching, and see you in the next video.